Hello and welcome everyone to SQL Friday. This is SQL Friday number 48 and our star today is Martin Guth. I don't know if I pronounced that right.
Perfectly.
Perfectly, Martin says. I think you're too kind probably, but thanks anyway. Today I am, well, as usual, I am in Sweden when doing SQL Friday, but I'm actually at home, so I have locked myself in a room because the kids are in the other room. But I think we're going to do okay anyway. We have a sunny day here in Sweden. I don't know for the rest of the world, but for me, it's a beautiful day, and what better could I do than hosting SQL Friday? Welcome to SQL Friday, Martin. I look forward to your presentation about the relaxed releases with DB-Workload-Tests.
So thank you very much, Magnus, and good Friday to everyone listening and tuning in as well. Greetings from sunny southern Germany as well. My session is on relaxed releases with DB-Workload-Tests. First of all, a few things to know about me. So I'm Martin, I'm 38, working for 11 years as a BI engineer, building new data warehouse, so analysis, business intelligence, that's where my passion truly lies in. But I'm also working for 5 years now as a DBA, primarily focusing on performance tuning and getting to know all the job from accidental DBA, okay, here's the server, to actually being able to handle stuff. So my current role, I personally would describe it like data Swiss knife. So being the one in charge and responsible for data, for analysis, for database performance, whatever. At 3C Deutschland, we are part of Experian, which is a bigger company, and I'm excited about PaaS since 2008. So now to the agenda of today. First of all, we talk a little bit about what's workload testing at all. Why do we do this? Then how to perform workload testing using workload tools. Have a look at some demos, typically the most interesting part of the presentations here in the technical SQL Server part. And then conclude with some tips and tricks, lessons learned. And I reserved some time for your questions at the end. So just type them into the chat as they are coming, and probably if we are progressing right positively, then we can have some questions in the middle as well. So lean big and enjoy. Why workload testing? So it's about a classic dilemma. We do a small change in a complex system, and we potentially have a big impact. Most of you would have experienced that, I guess. So, for example, as we are doing performance tuning, we could alter an index, we could add a column, we could throw a column out, and of course that has some effect. Queries are DML, so insert, update, delete, can get faster, or it can get slower. Or I can even do some server tuning, use new features like advanced database recoverability, which comes with SQL Server 2019, or be playing a little bit with Maxstop. And in all these things, I really don't know in advance what will be the outcome. So I have 3 courses of action. The first one is no risk, no fun. Let's just flip the switch in production and see what happens. The other thing, well, I'm too wary. Anything negative could be happening. So never change a running system. The system is running good. Do not change anything. Or, of course, test thoroughly in advance. And if you're interested in testing in advance, then stick with me for this presentation.
You are not sharing anymore, Martin.
Oh, okay. Then you could imagine how colorful the slides look. Let me just get back to
I'm closing my eyes and I imagine beautiful slides in the words, Martin.
Yeah. So you haven't missed much. So where's my here?
There it is.
Do you see it now?
I see it. Yes.
Okay. That was the thing I was just talking about. So let's go on. So yeah, testing sounds fine, but how do we do testing? How to go for this? And I thought about it, and there are basically 3 levels of testing. I could test a single query, which is probably the easiest one. Every one of us potentially has already done. I have a query having a problem with performance. I'm looking at it, take some modifications, testing in the original state and in the modified state, and then I can say, okay, that's great. Let's ship it. Let's put it in a release, and I'm done. I could be a little bit more cautious and say, okay, I'm altering something about the table. Let's test all the queries that hit that table, which is feasible as well. Or I can go to test the complete workload. And what's so different about the query and the workload? So workload, as I see it, is everything which is being executed on the server, which relates to read and write activity. So here it gets a little bit more complicated, as I'm also testing writes, but on the other hand, this is what enables me to have some relaxed releases, to be sure that, for example, an index change wouldn't have a drawback, for example, on insert performance. So now about conducting DB workload tests. How do I go? Which recipe can I follow to do this? So first of all, I've got a production system where I take a backup before I then capture my workload. So I have a starting point with the backup. I capture the workload. Then after I'm finished capturing, I can head over to my test system, perform a restore there, and then I do a first replay, just straight vanilla replay to get a baseline. I gotta know how does performance, how do the metrics look like on an unchanged system. So that's my baseline there. Then I do a second restore, and afterwards implement some changes, adding few indexes, flipping some options, whatever, doesn't matter here. And then perform a second replay. And afterwards, I can do some analysis between the 2 replay results. And typically, that's not one-way road. I would then detect, okay, damn, this one got better, but the other thing got worse. And this is basically what enables me to then later have some relaxed releases in doing the work up front and being sure that I've tested the outcome. So yeah, now I said we gotta have a test system. Okay, fine, but what does that mean? Some thoughts about this. So first of all, if you're thinking about a test system, you have to think about sizing. Typically, you want to run production workloads, and that of course means your test system does need to have sufficient storage capacity that the production database fits there. The disks can in fact be slower, but the capacity has to be in place. And talking about this, it's the same true for memory and for CPU config. And of course, I then have to look that I set the SQL Server settings identically. For example, maxed up. It makes a big difference if I'm running a query parallel on 6 cores, or if I'm running on 2 cores, or if I'm running single threaded. And of course, these days, as we set up these test systems, we have to watch out for GDPR and security as well. Just do your due diligence. So it's very easy for me to just note that here, but just have a talk with your security officer what would be possible. So I'm getting a little bit ahead of myself, sorry. Workaround. So yeah, that's not the perfect idea, but rather than you don't start doing anything, of course, you could think of having a separate database on your production instance for that workload test. You could then perhaps go, depending on your business, to run workload tests in off-peak hours. There are some systems out there where at the weekend nothing really happens and nobody would complain if they would be doing something else. But then you have to really to double check that your workload you're running doesn't access production databases, of course, because it's on the same system and it wouldn't be good if we do that. So, for example, have a separate logging without access to the real production database. So yeah, that's already a quick glance on workload testing in general. Now let's get a little bit more concrete. How do we do this technically to perform workload testing using workload tools? So first of all, what's workload tools? It's a great open source tool suite developed by MVP Gianluca Sartori. And I can do a workload capture using all the methods we have in SQL Server, which are profiler, trace, or X events. And it also supports SQL Server from very old versions like 2000. It's actually tested with 2005, but I guess that's sufficient of a history these days where these are even anymore supported. The capture gets then saved as a SQLite database where we'll have a look at after, and which is great because, yeah, we're database guys. SQL is our primary language, so we've got a great opportunity to play with the workload directly in a database with SQL. And it also has, of course, an integrated tool for replay. The most important thing, you can get it on GitHub. So let's have a look at the components. So first of all, we've got SQL Workload, which in my view is one of the most important components, as this is the tool where we do all the work with. It can capture and replay the workloads, and it's a command line tool. Then if we go for workload analysis, there's a great tool called Workload Viewer, which can be used to compare test results. So if we have these two workloads, then I can use a nice GUI to compare some basic metrics. And also a more special tool, if you're very long in the business of workload testing, you can convert your existing trace files with convert workload. And it was also planned to have some kind of wizard one day, which should be a GUI, but it's not yet available. And if you ask me, the command line tool is not too complicated. So it's I have some advice for you in this presentation. If you do your first steps, I'm pretty sure you'll get around with it very easily. So how is the configuration done? So there's this basic schema of having a database which can have one listener and multiple consumers. So the listener can capture from source, for example, with X events, read from a capture I already saved to a database, and then we can have consumers like we write a workload to a file the first time we record it, or we gather some analysis data using an analysis consumer, or of course replay the workload using a replay consumer. And all this configuration is done in a JSON format, which I will show you now. So first of all, here's a sample configuration for capture. We can see we've got a controller section, we've got one listener by these curly braces and multiple, potentially multiple consumers. Here it's just one. First of all, we are recording the workload using X events, which is told by that type. We are connecting to the DB server, my DB server, via Windows authentication. Alternatively, I could supply some login credentials and add a database filter to record just the workload of MyDB. That's already optional. You could just record the whole workload for all databases. And then we're saving the workload to a SQLite DB for subsequent replay. So how does the replay process work? Each recorded session, which means each spit, gets its own replay worker process. And this replay worker process executes the commands in this session one after another, which means we could have a possible problem that the sequence of execution on the test system may differ from that captured on production, because they run independently from one another. I could have, for example, an insert in SPIT 100 and an update of this just inserted row in SPIT 101, and the replay can result in a foreign key violation. That's possible. It's not exactly typical, but it's something you have to be aware of and just have to look out for. In my case, I've had this in rare cases, like 10% of the statements running into this condition, which actually isn't that bad, because I just still can get a general picture of what's happening. So what do we have for options for performing the replay? We can go for a synchronous replay, which we tell with synchronization mode equals true, or an asynchronous replay. The synchronous replay respects pauses in the workload. The asynchronous fires commands as quickly as possible, which means with a synchronous replay, the replay duration resembles the capture duration. If I do a 1 hour capture, I will have a 1 hour replay, more or less. And with the asynchronous replay, the replay duration can be significantly shorter, because, all the gaps, all the phases of non-activity are not respected. And which also means the capacity of the test system is pushed harder. And I also can get some more errors, like this foreign key violation, if I have more speed in it. So it just depends what you want to go for. I suggest just trying both. In most cases, to me, the synchronous replay makes a little bit more sense in interpreting the results. But if you, for example, say, okay, I want to have a look, what could it be if we have a little bit more intense workloads, you could use the asynchronous replay to have that test. Okay, having spoken generally about replay options, now let's look at the configuration. We have the same structure with controller, listener, and consumers. In this case, the listener is a file workload listener. We've just captured a workload in a SQLite database, and now we are reading from that workload, and we're saying we're doing a synchronous replay. And then we've got multiple consumers this time. First of all, the replay consumer, which names the server and the database where the replay is targeted at. And we've got some additional configuration options telling to discard the results after execution and to have a command timeout after 3 minutes. And then there's also an analysis consumer we use here, which writes some diagnostic information on the workload to a specified database. And it's really nice how Gianluca has set this up, that we can use different schemas for different workloads. So you can think of one big database for all your workloads, and then you can go differentiating them by schemas. The table names will all be the same in these schemas. And we are saying there that we would like to upload the results every minute. So that's just a basic configuration of capturing and replay. Now, we are, you are from Sweden, right? Magnus?
I am, yes.
So this was inspired by your big, great company from Sweden, IKEA, the furniture company, discovered the possibilities. There's more than just one way. So we can go for some advanced configuration, meaning we could do a workload analysis during the capture already, which I would like to call something like the mother of all baselines. So that's pretty nice. I could take a baseline from the production during capture. I could then replay, take another baseline, and I can compare them side by side and say, oh, okay, that's how things are on the real production server, and that's how it looks like on my test instance. Might be useful for interpreting the results as well. And we also can go for some really sophisticated setup in my view called real-time replay, where we don't need a capture file. We instantly start the capture on production and then the replay, and are then synchronizing that. And of course, that needs a little bit more advanced type of getting two databases in sync, like log shipping, which is a little bit too much from my point of view, what I typically use, but of course you can go for that. And Gianluca has written a great blog post about that, exploring it in a little bit more detail. So now we've got the capture, we've got the replay. Let's go for analysis of workload test results. And here we have two options. First of all, we've got Gianluca's workload viewer, which is integrated in the tool, which is a nice GUI. It shows the core metrics, CPU time and elapsed time. And as of now, we've got no execution plans in it. But that's not too bad, actually, because it's a great way of showing the more overall metrics and the changes per query as well. And if I'm a little bit more into performance analysis and what's happening in the planner, I've got a second option, which is not which can add to this. And this is a query store comparison script written by John Starrett. And this covers reads and writes the analysis. And of course, I've got execution plans available from Query Store for in-depth analysis. So sorry, I take the word Query Store for granted. Anybody who doesn't know about Query Store, don't feel ashamed. It's perfectly okay. It's a great performance tuning tool. We've got it available since SQL Server 2016. And it offers you to store information about performance and execution plans into a part of the database, and makes performance analysis and plan forcing much simpler than we had it before. So if you're running SQL Server 2016 or higher, and you've never played with query stores, I would highly recommend to give it a try if you are some kind into performance tuning or interested in this. So, and before we gotta have a look at the demos, I would like to share with you some community spirit and why I think this is such a great tool. So I had a problem with Query Store, and Gianluca shipped a new release in just one day. I think, guys, this is absolutely amazing. This guy, Gianluca, is doing this in his free time, as many of us in the SQL community, Magnus with his SQL Friday as well. And I think that's really great that we're really out here helping each other. I've just written him, oh, I've got some problems, and then he just went over the code and said, okay, I've added a fix which addresses some of your points. And I think that's great. If you look at Gianluca, he's very active in this project. There's a new release at least every month, I think. And good thing to see there are also some other people catching up and contributing to this. So for me, it's not that easy because that's C# code, but God bless them. There are a few people out there who know not only SQL Server, but programming in C# as well. So, okay, fine. I'd say let's go directly for the demos and have the questions at the end. So I first show you how to record a workload, and I've done this in a video because it's much easier for me primarily of setting up the workload that I don't have to click here such 200 times or so, then I can easily show it to you. So first of all, we've got our JSON file for capturing, which is quite the same we already looked at beforehand in the presentation. We're capturing using X events. Here we are connecting using username and password. That's because my local machine's using Docker SQL on Linux. And I write to a SQLite database. And I've set up a little PowerShell script to handle the workflow recording, which is basically doing a little bit of syntactic sugar. I'm starting a mark transaction, more about that later in the presentation. And the really important line is line 23, where I call SQL workload-exe with the JSON config file and tell him to log the output messages into a specific folder. Okay, and then we are just starting this. So and now it goes writing event data, etc., etc. And of course, I'm performing this on my local machine, and I've got no workload whatsoever. So I came up to set my own workload, and that's where things get here a little bit nasty. I'm using the free tool SQL Query Stress to fire some workload query at the Stack Overflow database, and we can see, okay, we have a workload running here, and now that's recording, and I've set it for 30 minutes to record the workload. So you can see that all here. And then we are jumping a little bit forward in time because that would now be rather boring to watch at this for 30 minutes and my time would be up. So yeah, we're now at minute 29. And if I now would like to be done with this, I simply go back to the window of the PowerShell window here. So I really like PowerShell, guys, but this works with CMD as well. You don't have to go into PowerShell, and we hit Control-C or just hit the stop button here, and then we've got the shutdown message. Typically, where does it come? Sorry. Yeah, here it was, which says closing connection, disposing X events workload listener. You can make a double sure checking on the production that the listener is gone as well. But this is really solid programming. And I also really like the way Gianluca has set up the X events listener in this case. So this is just this has no big file associated to it, which could overflow the drive or something, as it only has a small buffer. And even if you leave it on, you don't risk running into any problems with this. But of course, you have the X event little small overhead associated to this. But we all know that X events are pretty good, are a little bit better than classic old profiler. So now let's have a look into the captured database. So here we've got the SQLite database, and I'm opening this in a tool DB browser for SQLite, which is kind of SSMS or query editor for SQLite databases. And I can see I've got 4 tables. And the most important table is the events table, which here has all the information recorded. And I just try to get this a little bit wider, but I'm stuck. Okay, we managed with that. So I've got some basic information like the start time, which app this was, which database, which server, session, and so on. And then here I've got basically the command. And I've got also metrics like CPU, durations, reads and writes in this file. And you can also see that there's a table counters, which where all the performance counters like CPU usage were recorded, which is also nice. So basically, we spoke about that general baseline from production. Nice thing is I can generate that even afterwards because all the information I need to do that is already included with the capture. So, and of course, if there's something I would like to modify, that's the great thing. I can go here and type some SQL. Of course, that's the point where things get a little bit more time consuming, but we have this possibility, and I think that's absolutely great. So, okay, we had a look at how to capture replay. Now let's have a look at how to actually capture workload. Sorry, getting ahead of myself again. Now let's have a look at how to do the replay. So I've got a notebook for you, an Azure Data Studio notebook. I guess this is pretty popular these days, but however, who hasn't heard about it, it's a really great way of coding SQL code and also doing some documentation about it. You can see I've got here some documentation, what this is about and so on. You can simply write in this, and here I've got a query code, and I can execute it hitting this play button. And the great thing is this is a great strategy as well as a presenter. If now my server goes haywire, I could simply show you this notebook and say, okay, this is the output you could expect from that. So first of all, conducting the replay, we said we gotta restore the backup. Okay, we gotta do this here. We restore the Stack Overflow database to the original state. We took the backup before. So if you're running on a Windows machine, you would like to adjust the path, which was of course Linux here. But apart from that, this pretty straightforward, I hope. So, and then next thing we would look like, I make sure that query store is on and configured appropriately. As I've already said, query store is SQL Server 2016 and higher. But another great thing, any edition, as far as I know. So you could then go and say, set query store on, and I here configure query store to capture all queries. So this is a configuration just here for demo purposes that I'm sure that I'm capturing all queries running. Probably if you are, oh, operation was canceled. This is interesting. If you're running this on your production server, maybe you're going for different settings. And then we are creating a database for all the workload analysis results. So I create a database called workload analysis, add a schema baseline. So you could choose any names you like. These were plausible for me. I'm just checking, okay, I've got no tables present. The schema was created. And then I can go for the replay. And here's my configuration JSON file to do that, which is pretty much like the one we've seen in the presentation. I'm reading from a file workload listener in doing a synchronous replay. And then I'm writing the results to an analysis consumer here every 30 seconds. and the replay is happening on my local server at database Stack Overflow 2010. And I've got some optional settings here as well, which you can read about here. So now I will go to start that replay, which is basically, as we've seen, calling SQL workload exe with the replay JSON config and the log. I've already prepared the tier in PowerShell, so we can just execute this one. And then we can see that there's some replay running. So we've got some messages, and it's getting very quickly. Okay, interesting. Now that's typically that I now get the error messages in the demo. Oh, wait, hang on a second. This was the previous run. Anyway, I've got now 3,000 events queued for replay, and it's writing some rows for analysis. And if I now head over to my database and execute who is active, I see that, yeah, there's something happening on my local database. So this was all we want to go for it. So basically the workload I'm running here is doing some selects and also some modifications. And this could now run for 30 minutes, which again would be kind of boring. So I'm canceling that off, hitting Control-C at that stage, and it's telling me it's shutting down. That's perfect. And we can go on having a look at how to go on after the replay would be finished. So what would I do? I then would do the clone the database. Database clone sounds pretty interesting for the ones of you who've never heard about it. A clone is all the metadata of the database, which means the table structure, statistics, and here comes the relevant part, query store. So if I want to save the query store for a database replay, a very elegant way is just to clone it. It doesn't take much space because, yeah, it's just the metadata. So this would the command to perform it there, and then I would see there's some information in it. And then I could go for the second replay. Here do some here just set up the objects again, and then introduce a schema change. Here I'm just creating some indexes, and then I would just run the second replay, clone the database again. So that's all about replaying. As you've seen, you have to be you have to know a little bit about the JSON, but it's not too complicated. You just tell Workload Tools what you like to have, and then you can run it, and it works as a charm. So now we've done all this capturing, replaying, but yeah, for what purpose? We want to do some analysis how far it brought us. So now for the really interesting part, let's look at the analysis. So we've got a notebook for analysis here as well. First of all, I'm restoring my workload analysis database because I've already fiddled around with it for this example for the replay. So here I've got a backup for it with 2 executed replays. That's fine. And now I'm running Workload Viewer. That means I can now just go ahead here and say run. Well, yeah. And I'm running it prepared with telling it the database, the schema, and the login credentials for the baseline and the change I did. You can also run it with no parameters, which gives you then a window with some fields where you can enter the details. So now that's loading. It takes a little bit longer than expected, to be honest. I am not quite sure what my machine is doing here.
My experience is that when I prepare demos, I have timed them, and then I connect to a Teams meeting and I run the same demos, and they take twice as long because Teams is using up resources on the machine.
Ah, yeah, that could be, Magnus, but actually this there I am already. I started this beforehand. That could be the explanation. So actually, that workload viewer, I think it's not too bad in kind of resources. You know, here the really hard work has already been done, which is the replay and the capture and all the things. So what do I see here? I have the metrics compared. So I've got here graphs for the baseline and the benchmark. Benchmark means the change. And I'm sorry, I've got no pretty pictures here because, you know, that's just my personal machine here. That's my Surface notebook, and the workload is not really that big in real examples. You would then see, okay, I've got a baseline like taking then and then long, and my benchmark would finish way earlier. Well, a little bit, but that's not really measurable here. I can see the same for duration and batches per second, and I would now have the ability, if I would like, to hit control and well, yeah, I can zoom in here a little bit. I've written about this you can read it all up in the notebooks. We've got a queries tab as well. So here's the view on the individual queries run. And Gianluca has set up this quite elegantly for the experienced performance tuners from the group. You typically know what an ad hoc query is. It's something like select star from DBO cities, where city equals Stuttgart, city equals Oslo, city equals New York, or whatever. And in SQL Server, I typically would get a separate plan for each one of these ad hoc query, and then this tends to add up and to be a real mess. So Gianluca has already aggregated them together. So if you have these kind of ad hoc queries here, you would find them in one hash here. And I can see what was the duration in the first run, in the second run, is there some difference, CPU reads, and so on. And I can also go on query level and then can look for one query how the measurements are different between the two runs. So this is really a great tool. And guys, once again, this is free, and this is from Gianluca's free time. So it's absolutely amazing what he set up here, and it already enables us to get some conclusions from the workload, if it's a little bit more sophisticated than mine here on my personal machine, I have to add. But of course, if you are into performance tuning, and if you're then analyzing the changes, you would say, okay, I need a little bit more. And then you can go for the option from John Starrett. So here we have his script. And basically, first of all, I'm transferring all the tables from the cloned databases into my workload analysis database. So my clone reads Stack Overflow 2010 baseline, and I'm here inserting the data. Here's some aggregate table on this, and then I can get a little bit fancy and say, okay, what's a great use case for clustered column store indexes? Let's use them here on the query store information. Well, to be honest, for this tiny demo, that wouldn't have been necessary. But hey, here you have a scenario. You could use them. Of course, you would need to run SQL Server 2016 and higher, I guess. And then you can query this this information. But what's really interesting comes here at the end. This is an analysis of differences. And here I can see, let's look at this. And now my view is a little bit stuck. Here we are. You can see, okay, execution delta 0. I've executed the statements the same, which is quite important for comparison. But I've got a duration delta in seconds, which is 1,174. I've been faster with CPU, with reads, with whatsoever. Well, this is kind of expectable in my constructed workload here, doing some pretty nasty stuff just on tables with a clustered index and then adding some indexes, which really helps these queries. But on the other hand, I can also see, okay, there are also some statements which actually had to do a little bit more, and which did go slower. And if I scroll right to the end, you can see, of course, that's an insert or an update. These are statements which modify data. And then if I slam a few more indexes on the table, of course, these would have to do some more work. And so, yeah, performance tuning and indexing typically is about finding the right balance. And one thing I really love about Azure Data Studio, you can also have a visual of this. We are pretty much used looking at all the tables, but this also tells quickly the story that we've got better performance nearly all over the place. And even these few queries which take a little bit more of resources, they absolutely diminish compared to the reads and the execution time we save with the most expensive queries. So much for the demo. Now let's wrap this up in 5 minutes. First of all, tips and tricks. A logging table can come in very handy for debugging how the workload is progressing. So what do I mean? You just have to have a new table where input results are added quite frequently. Typical systems are very chatty and also have some debug log or something like this. If you don't have one, just add a new record every minute. And then you can set up a Create SQL to say, okay, I'm now 30 minutes in the replay. I should be 30 minutes with the data, but I'm only 10 minutes in it with the data. What's happening there? Is it stuck? What's going on? And that's a great tool if you are first into conducting replays where you can get a little bit more confidence in how to execute them and some progress monitor. Then optimize the restore. First of all, we've seen we've got point in time restore using log backups. That means typically in your production databases, data changes every second, millisecond, or whatever. You can't say I take the backup from this night and I'm starting the replay at 9 o'clock. This typically won't work because there's so much data being altered in the intermediate between midnight and 9 o'clock. So you typically have log backups to apply. Just run a mark transaction, which reads something like this. You say begin transaction with mark, like capture start, and then you can store exactly from that mark. Of course, you could also use the time and use with stop at, but that's a little bit more clumsy, to be honest. And using such a mark is a great way of having that repeatability and don't have to change things over and over. And then you can use database snapshots to speed up subsequent response. And this is also available in standard edition starting with SQL Server 2016. So what actually does a snapshot do? It's pretty much the same like snapshot at VMs, for example. It stores the modification somewhere else, and then I can set back to the original structure, and this typically does go way faster than restoring everything from scratch. So some lessons learned from my side. First of all, workload tests are a complex topic. Make sure to reserve enough time. I hope I made a little contribution for you to start a bit easier than my rough starts were into this topic, but it doesn't make sense that you say, oh, I'm carving out half an hour today and half an hour 2 weeks later. Just reserve like 2 or 3 days to get started in this. Otherwise, from my point of view, you have too much time to go over and repeat where have I been, what do I do. So it makes more sense to approach it in that manner. And of course, there are interesting things to discover in your own databases. I'll just leave that as it is. Occasionally, it may make sense to manipulate a workload, which means you would like to change things. Of course, then it's not exactly the reality, but sometimes we would like to simulate something, and that's something you can perfectly do using workload tools. And just be aware that all activity is recorded, which also might include backups. Just watch out for them and ensure at least that a replay can't overwrite the production backups. So from my point of view, I use Ola Hallencrane scripts, and I haven't seen them being reported, mainly because I'm running them from a completely different database than I'm recording the workload from. But just make double sure that this is not there. And at least if you use Ola, you've got a different timestamp and you're not overriding your original backups, which would be really important. So some lessons learned for me about presenting as well. This is my first community presentation. It's not the first time I'm giving it today, to be honest, but yeah, less is more. Question the scope of your presentation at the beginning. Yeah, and now my timer's catching up anyway. At the beginning, I wanted to do much more, and then you realize, oh, there's only so much gonna squeeze into that time frame, and I hope you got something about it. For demos, yeah, that's a tricky thing. You needed much more time. It's not that easy to set up a workload from scratch. And yeah, that's the thing I also said. And basically, folks, that's it. I've got here some resources if you want to read on. So Brent Osa has some great resources. I, of course, get Workload Tools from GitHub, read Gianluca's blog. And if there are any questions, I'm now very happy to take them. And yeah, just contact me or Gianluca if you've got some questions afterwards.
Martin, thank you so much.
Yeah, Magnus.
I'm already a big fan of Gianluca, and I completely agree with everything you say about the community being fantastic sometimes, and Gianluca is one very important part of it. And I think it's worth mentioning that he's not only doing the workload things. He has presentations and bundles for monitoring as well that he's also maintaining on his free time. So it's nice to have these people. I know for other products, other database products, the open source community isn't as vibrant as it is for our community. So I think it's really nice to have all these people here. We have something in the chat here from Bola. Thank you. Can you please share the link to the resource links? And there is already a link in the chat to Guth.de/presentations, where the presentations are. So I think the slides are there, right, Martin?
Yeah, right.
And then in the slides, you have all the links.
Yeah, exactly. You can download a zip file, which includes the presentation and all the demo material, so all the notebooks and so on are included.
I have one thing about when doing the replay, or basically when doing stress testing. I always try to, if I have an influence of the environment where I run the performance test, I always want them to be slightly less performant than my production. Because the idea for me is kind of, if I have an SLA, I have to take on this workload. Say I have a batch that I need to complete in 5 minutes. If I can do it on a crappy machine, then I know that I have some insurance for unexpected things to happen in production where I have better performance. So that's my one. If I can finish on time on a lousy machine, then I can for sure finish on time on a good machine.
Okay, thanks for that idea.
But there are other things. If you run it on a slower machine, then maybe you don't get into the same content because you have fewer CPUs, for example, so you won't have the same level of infrastructure. So it's a double-edged sword. I see some thank yous in the chat, and thank you so much too. But
yeah,
this was your first presentation that you made, but this isn't the first time you presented it, right?
Sorry, I didn't get that.
It's me and the microphone again. You said in the end that this was the first community presentation you made, but it wasn't the first time you presented it, right?
That's right. That was actually the fourth, but I thank you for listening, and I realized there are so much people out there. Typically, you can't expect giving more presentation once and having everybody realize. So it's a great pleasure to me. And as with good wine, it gets better each time, as you might have experienced yourself, Magnus, probably.
Yeah, and I laughed when I saw your tips and tricks in the end about presentations. I'm never able to present all the material I have in a presentation, because even if I time it before and I know that this is going to fit in 55 minutes, no problem. Then I start presenting it. I realize when I show an execution plan or something that, I need to mention this as well and this as well and so on. So I always have to cut some things in the end, which is it's not the end of the world, because people listening, they don't know what you didn't present. They only know what you did present. It's kind of a stressful feeling when I say that, okay, 10 minutes left and I'm just halfway through.
But possibly thinking about it, this is also something you can also then tailor the presentation to your audience. If you then know hands up how many performance units are in here, what are your challenges, then you're probably going a little bit more on one topic than the other. This is what I admire about professionals like you. That's something I'm still striving to get at. But how a German word says, the more you practice, the better you get.
Yeah. We had a fantastic alpine skier in Sweden, and he just won everything. And then in an interview, someone said that he was really lucky so often because he won by 100th of a second so often. He said, yeah, but it's kind of interesting. The more I practice, the more luck I get.
Okay, cool.
Yeah.
Well,
thank you so much for coming. And I'm going to try to do the editing. It's not going to happen this weekend, but hopefully on Monday morning I can do the video editing and upload the presentation to YouTube.
That's cool. Looking forward to it. Okay.
The link to the presentation as well in the comments. So thank you so much.
Yeah, thank you as well, Magnus. Have a great weekend ahead, and every one of you as well.
Yeah.
Bye.
Bye-bye.